But it'll also be relatively easy if you've been paying attention. Okay? Right? So breathe with me. Trust me, I'm not out to get you. I've been trying to help you all year. Okay. A couple more comments about this before we move on to the next problem. If this had been any ellipse, this would be the major axis, and this would be the minor axis, right? In a hyperbola, those axes are still there. There's one of them here, and one of them here. But now their names are transverse axis, and you won't forget that because trans means across and verse vertices. So this is the one that connects the vertices. It is the important one, but it doesn't have anything to do with length. It has to do with which one joins the vertices. This other axis is called the conjugate axis. And its purpose is simply to help you build the box so that you can put in your asymptotes and sketch your curve.
So if y came first, would the transverse and conjugate?
This would be transverse.
Okay, yeah.
Wherever the vertices are, that's the transverse. Now, tell me about these asymptotes. If I wanted you to write the equation, these are lines. If I wanted you to write the equations of those lines, you could do it. Because what do you need to write the equation of a line? You need a point. Do I have a point? The center? I mean, I have lots of points, but for sure I have the center. And then I need the slope. Now think about this line right here. How did you get this corner up here? Did you draw that line down through? You counted up 4 and over 3. So the slope of that asymptote is positive 4/3, and the slope of the other one would be negative 4/3. So if you needed to write the equations, you absolutely could. You have everything you need to do that. Now, FYI, I don't think we're going to dig this deep into it because Unit 4 has a lot of stuff in it. But if I extend my transverse axis, the foci would be back here inside the curves, just like they are in a parabola. And we can find those points. There's a technique to find them. We're not going to do that. I think that's all I wanted to talk about with that guy. So let's look at the next problem. B. It is another hyperbola. How can I tell? Subtraction, squared, squared, and subtraction. So if I had a list of equations in front of me and it didn't say what they were, I could tell that one is a hyperbola because of the squared minus squared. All right, you're sketching it by hand. Here we go. Where's the center?
-2, 1. 1, -2.
1, -2. That is a trap.
I was just messing around.
That is a trap that people fall into all the time. Every point you ever write in the Cartesian coordinate plane is going to be x, comma, y. Brian,
Yeah.
if you screw up your center, as my friend Zach Meeks says, you are cooked because everything comes out from the center. So we got to get that right. So 1, -2 is my center. Now, what does this 25 tell me? 25 under y tells me to go 1, 2, 3, 4, 5. So that's going to be 1, 3. And 1, 2, 3, 4, 5. That's going to be 1, -7. And then the 2 tells me to go -1, -2, 3, -2. Everybody okay with those 4 points? So what do? Hyperbola, so I build
Make it
a,
square, a rectangle,
yep, a rectangle.
and then draw the diagonals.
Draw in the diagonals. And then I gotta sketch my curve.
And Y is first.
Y
So it's
is
gonna be,
first.
it's gonna be the top
It's
and the
gonna be
bottom
up and down,
vertices.
that's exactly right, here it is.
And then,
Just a second, everybody keeping up? Okay, so what else were you gonna say?
the conjugate be the left at that one. and then
Conjugate
the
is this,
trans-
yep. So if the
transverse.
question said, how long is the conjugate axis? You would say the conjugate axis is 4, because we went back and forth, 2. This is the transverse axis, and it is 10 units long. And how about my asymptotes? What is the slope of my asymptotes? 5 halves. Plus or minus 5 halves? Because when I built the box, I started at my center and went up 5 and over 2. So my slope of my asymptotes is plus or minus 5 halves. Pretty good? Okay, now, we got this one sketched kind of by hand. Now we're gonna do it on our calculators. Calculator will not sketch this equation as it is. So we're gonna have to find the implicit function. So we're using that hyperbola right there. So let's move the x quantity over. Everybody okay with that? And then let's multiply, well, actually, it doesn't matter. You want a square root first? We could do that, or we can times by 5 first, it doesn't matter. Or 25, I mean, what do you want to do? Multiply, so we're gonna have y plus 2 squared equals 25 plus 25 x minus 1 squared over 4. You have got to make sure that you multiply everything by 25. Now we'll square root. So y plus 2 equals plus or minus the square root of this mess. And we're not in Algebra 1. We are not going to square root these. Guys, when you put a plus sign in there, you're not going to simplify that. Okay? You cannot say this is, oh, I can just take the square root of everything. No, you can't, because of the plus. It's like saying 3 squared plus 4 squared is 5 squared. But when you square root that, 5 does not equal 3 plus 4, right? It doesn't work when there's a, leave it like that, and then subtract 2. Now, these equations always look hideous. By the way, that's 2 equations. We're gonna have to put them in a separate equation. One positive, one negative. And they always look so bad, but our calculators do a good job. And tell me if you get what we thought we were gonna get, which is that guy right there. Did we get it? So when this is not a function. Doesn't pass the vertical line test, right? We got repeated y's, repeated x's. No, not a function. However, when you made them implicit, the positive one gave you the top branch, and the negative one gave you the bottom branch. Is that okay with everyone? Okay. Then, let's do that last problem in the hyperbola section. You're gonna write the equation of the hyperbola. So you're gonna write something, well, I erased it, but it's gonna look like B, equation B looks. So you're gonna have something squared over something minus something squared over something equal to 1. You know the transverse axis and points, also called vertices, and you know the slope of the asymptotes. So see if you can come up with that equation. I'm working on something here. All right, what'd you come up with? Anybody come up with something here?
Yeah.
What you got, Jack?
I have x minus 2 squared over 9. And then I have y minus 3 squared over 16.
Everybody okay with that? All right, now I need you to squeeze in one more. I just realized I didn't include one where you have to put it in standard form. So we're gonna do one more problem. I want you to take this equation right here. And I just put it together, so I'm keeping my fingers crossed it all works out. I want you to figure out, I want you to sketch that guy. Sketch it. Which means you're gonna need to get it in this shape. Would you agree with me?
It's like the same way as the other one, it's just a different.
So take a second, think about, first of all, in a list, would you recognize this as a hyperbola? Squared minus squared. It's the only one that's squared minus squared. Anybody feel like doing the first step on the board?
I can get it. Easy.
Okay. Just one step, whatever you would do first. Go ahead, yeah, you can do the next step.
Want me to hop in? We can finish it together. We both did part of it.
Oh, yeah. I'm gonna add the 4.
Go ahead, do everything you need to do.
Yes, you do.
So what's happening here is your life would be so much easier if you would actually like show what you're doing here. Okay? Alright, so what do you put in here to complete the square? 4, so put a 4 there. But that 4 is being times by, so it's really a, here we go. Now,
But I thought you did 4 divided by 2, which is 2 squared to 4.
You get 4 on each side, but everything you get plus 1 on here.
Oh, so
There's no
over here.
parentheses on the other side.
So
For the other side, you're adding 36 instead of 4.
alright, how does it look? He ended up with x plus 1 squared over 9 plus y, or excuse me, minus
Oh,
y
minus.
plus 2 squared over 1. What you got? Everybody okay? So where did you put your center when you graphed this thing? -1, -2. You counted sideways 3, up and down 1. Built your box, and then drew the hyperbola sideways.
No. Up and down, right?
No, it's sideways, it's sideways.
No, it's X.
Which letter
No,
goes
it's
first?
X first, so it's
X
No, I decided with Y.
In a hyperbola, yeah. I mean,
Oh, yeah,
this
I'm
is why.
confusing myself. I don't know why.
This is why.
That would make sense. That's me.
Now, Brian handled it, nicely. A lot of times there's a mistake here because people aren't careful. When you factored out this -9, that becomes a positive. And again, you have to be careful because that will screw up your center and then it's all over. Okay, perfect. All right, get out your extra practice. And I don't want to overwhelm you. All right, but I want you to do, for sure, problem 6. I gotta get my numbers straight here. So I want you to do, all right, we're gonna do 4C. B and C, and all of 6. All right, so you're gonna do 4C, 5B and C, and all of 6. Okay, those of you that didn't do last night's need to bring that to me tomorrow also, okay? All right, it's important we practice this stuff. Got it?
Wait, so it's C for 5, B,
And C.
and C, and then it's 6?
All of it,
All of 6?
yes.
Got it. Thank you.
My brain